Hi everyone. So we're starting a new unit on functions. Today we're going to focus on domain and range, mostly functions with the graph. We're going to look really into the graph of a function. The do now is a worksheet. It's basically a situation, and you need to look at the different pictures and identify which is which. So look in the file for that. Okay, a relation. A relation is a relationship. It's any mapping of elements in one set to elements in another set. So in high school, we really focus on numbers, right? If you end up becoming a math major, anything like that, you could get into some stuff other than numbers. Like, oh, this square is really mapping to a circle and weird things like that. Okay, domain. There's lots of ways that it's taught throughout the years. It's your inputs, it's your independent variable, it's your x values. Basically, it's the values for which something is defined, right? What am I allowed to plug in? So if I say my my relation is a blender, what am I allowed to put in a blender without it being destroyed? I can put in ice, I can put in food, lots of different food. If I put in rocks, it would be destroyed, so that wouldn't be in the domain. The domain would be all the food that I'm able to put into a blender. And then range, that's our output, our dependent variables, the y values. It's everything we get when everything in the domain is plugged in. When I plug in every single domain, all the stuff I get out is the range. And then finally, what is a function? Each element in the domain maps to exactly one element in the range. So this is important. Exactly one element of the range. So if my domain is things I'm buying, right? So I buy a coffee, right? The range is I spent $1.06 at Cumbies, right? What can't happen is if I buy a coffee and then Amelia buys the same coffee and she spends 94 cents, right? That's not a function, right? Not a function. Because we're buying the same exact thing and spending two different amounts. Our X is the same, our Y's are different. That is not allowed. But think about it this way. I buy a coffee for $1.06. Amelia buys a soda for $1.06. So the Y's can repeat. It's the X's can't. So you can't have one thing in the domain going to two ranges, but you can have two ranges going to one number. So if buy a coffee is one thing and then the other thing is buying a soda, we're both allowed to go to the 106. The buy a coffee can't go to two numbers though. Okay. There are five, actually this is a lie, I disagree. I think there are 6 ways to represent a function. We're going to focus on 5 of them. So the first is just listing points. So this is called discrete, where you just have a bunch of dots, okay? So look at A and B. Are these functions? What do you think? So A is not a function. Why is it not a function? The X value, 3, is mapping to 2 different Y values, right? 3 maps to 2 different Y values. So that is not a function. How about B? Is B a function? B is a function. If you look at your X's, they are all different. Now, the Y's, we do have a Y that repeats, but remember, that's okay, right? The fact that those 2's are there, that's okay. That's allowed. Yes, a function. Right. All X's map to one Y. You are allowed to have repeating Y's, though. And then, see, I see this as the same as the last one. That's why I'm like, I don't know that I don't know where I got this from. They break these up. But using a table and listing points, to me, are the same thing. Okay, so using a table are these functions. So the first one is a function because if you look at your x's, they're all different, right? Each x is mapping to one y. However, in B, this is not a function. 2 is mapping to -4, and 2 is mapping to 7, so this is not a function. Now, we haven't really talked domain and range because these are silly. The domain is just all your x's. The range is just all your y's. However, when you talk about what you're supposed to do for domain and range is when we have just a bunch of points, we just list them. We use the funny bracket. And my domain is 2, 5, 0. Now, we're not going to write the 2 again. We're just going to write the -11. Don't ever repeat the x's or the y's. So the range is -4, 0. I'm not going to repeat the -4 again. 7 and 8. So my domain is just listing all my x's. My range is listing all my y's. And you can still have domain and range even though it's not a function. All right, next we have a graph. We're going to spend most of today on graphs, but this is another discrete graph, right? Discrete is, again, where you just have a bunch of points. So take a look at this. Is this a function? This is a function. Every x maps to exactly one y. And here's the trick for this. Here, I'm going to throw one in here. This is not a function now. Why is this not a function? Because 4 maps to 2 and 7, right? This number 4 maps to both 2 and 7. So that's not a function. Here's a quick way on a graph to tell. It's something called the vertical line test. If I draw a vertical line through this, I hit 2 different closed dots. So the vertical line test fails. I hit 2 points. All the other ones, right, if I draw a line through the graph, I'm only going to hit it once. So that's the easy way. If you draw any vertical line anywhere on the graph, will it hit more than 1 point? If it does, it's not a function. Vertical line test hits 2 points. 2 points. So it's not a function. Okay, so this one. Now, keep in mind when you look at these that you have arrows really on the end. Think about like the graphing calculator. They don't put arrows on the end. So just assume there are arrows. All right, so is this a function? If we draw vertical lines through it, will it hit more than once? Now be careful with this rule because some kids are like, oh, I'm hitting more than 1 right here. Yeah, you're really not though. Like it's coming close, but this is definitely a function. Okay, now this is not discrete, right? Unlike those other problems where it was just a bunch of dots, this is not discrete. This is a nice smooth curve, right? We've graphed these. All right, so let's go through domain and range. Domain, remember, is all our x's, right? All the x's. The x-axis goes left and right. So here's how I do these. I write it in interval notation. Interval, it looks like a point, but it's not. It's going to be left, comma, right. Because the x's go left and right on the x-axis. Your range is all the y's. The y's are up and down, so that's the lowest, comma, the highest. So now we're not looking at the points on the x-axis. We're looking at the red graph. Where on this graph is the red graph farthest to the left? Farthest to the left is up here, right? That's an arrow. What's an arrow mean in math? It means it's going on forever. That's the symbol infinity. But remember, we're going left because we're going this way, and our x's are negative on the left. So our domain is negative infinity. And then we're going to look what's farthest to the right. Farthest to the right is also an arrow. Now, be careful here because the arrow is going down. So a lot of kids are like, oh, it's negative. But we're talking the x values. This thing is going this way. It's going down pretty fast, but it's the positive x values. So my domain is negative infinity to infinity. You could also write out the words all real numbers. There's lots of options here. Okay. Now for the range, the lowest comma the highest. Now I actually circled the lowest. This point is also farthest right. It's also the lowest. Now lowest, this is the y. The y is negative. So negative infinity. And then the highest is up here again. It's that same arrow. It's going up. So that's positive infinity. So this is what we're going to focus on with graphs. Okay. Now using an equation. So you can, we use equations mostly, right? So we are going to do this on another day. I'm going to focus on finding the domain, range, and is it a function. This one is actually not a function. Let x equal, plug in x equals 11. What do you get? You plug in x equals 11, you get 11 equals y squared plus 2. Y squared equals 9. And then how do you solve for y? But remember, when you take the square root, you're supposed to do plus or minus. So the point 11, 3 and 11, negative 3 is on the graph. So this one is actually not a function. Basically, anytime you see a y squared, y to the 4th, y to the 6th, it's not going to be a function. This is a line, so this is a function. We know about equations of lines. All right, and then the last one's a mapping. This isn't used so much in higher level math, but it's used, you should have seen these already. So is A and B, are either of these a function? A is a function, so this is a yes. All the x's are mapping to something different. How about B? That's a no. And what's our reasoning? Negative 3 is mapping to negative 10 and 8. Notice that 1 is left off. It's a loser. It's got no friends. That's a thing. That's okay. You don't have to worry about that though. Okay. So now we're going to spend some time looking at graphs and finding the domain and range. So really look at the left comma right and then lowest comma highest for this one. All right, so what x value is farthest to the left? Negative 2 right here, right? What x value is farthest to the right? 4. Now notice I left, I didn't put the parentheses around them because we have to write something else down that I haven't talked about yet. Right, what's the lowest? The lowest is down here. What's that y value? That's negative 6. And then what's the highest y value? Up here, that's a 2. Okay, so now, if you remember from inequalities, when we had an open circle, it was like a less than, right? That's a parentheses. Whenever you see open circles, you're going to do parentheses, an open circle or an infinity, right? We're going to do parentheses. However, in this case, we don't have open circles. We have closed circles. So because we have closed circles, we're actually going to use a bracket. A bracket means we can actually equal it. So the domain is all x values between negative 2 and 4, including the negative 2 and 4. The range is all y values from -6 and 2, including the -6 and the 2. If we put parentheses, that would mean we get close to -6, we never actually reach it. All right. Pause. How about this one? So domain, farthest left. Be careful with this one, kids. This one's a little hard, actually, because of the graph. So we're at -3, and there's a closed circle. Farthest to the right, that's actually 4. 1, 2, 3, 4. A lot of kids put -3 and 3. I've done that before, too. All right, and then what's the lowest y value? That's -1, right down here. And then what's the highest y value? Both of these hit 5. Done. All right, try these two. All right, number 8, pretty straightforward. Farthest left is -9. Farthest right is 7. The lowest, let's see, that's 1, 2, 3, 4, 5, -5. And the highest, also 5, 1, 2, 3, 4, 5, yep, -5 to 5. Okay, so now this one, notice we have an open circle. So farthest left is -5, but it's an open circle, so I'm going to put a parentheses. And then farthest right is 5 also, but that one's a closed circle, so I'm going to put a bracket. So you can have 1 and 1 on each side. All right, what's the lowest point on this graph? -2, and the highest point is 2. Now here's the question. The top, we've got the graph, so it's a bracket. Now, is the left one a bracket or a parentheses? Because we have an open circle here. But because of these points over here, we do actually hit -2. So you are able to, like, we filled in that circle, really, with the domain, with the other point. All right, pause and try it. All right, farthest left is -4. So it's -4, comma. Farthest to the right is an arrow. What's an arrow again? That's your infinity. Range, what's the lowest point on this graph? Lowest point is right here, that's our -3. The highest point, again, is an arrow going up forever. All right, now, before you do this one, we haven't seen these dotted lines before. This dotted line, it's called an asymptote. It means that the graph gets really close to 3, but it never reaches 3. So it never actually reaches 3. And then notice there's the lack of arrows. There are arrows here and here. Okay. All right, so this one's a little tricky because we haven't really done a lot with graphs like these. So take a look at it. You're actually going to need 2 different intervals. So farthest to the left is -2. And then farthest to the right is we're getting really close to the dotted line, the 3, but we're not reaching it. So that's a 3 and then a parentheses. So that's the first one. And then, so now we're done with this side and we have to jump over here. We have this that also is getting really close to the 3, but not reaching it. And then on the right, we have a right arrow, so infinity. Now, whenever you have 2 intervals, we put a U between them. It's called the union of the sets, right? We have a set of numbers and then a set of numbers. To show that they're both part of it, we put a U. All right, the range. So what's the lowest thing we see on this picture? The lowest point is, again, an arrow, right? So that's -infinity because it's the y values being negative. And then what's the highest point? Well, notice this piece, right, comes up and it hits 0 and stops. So it's 0 and it hits it, it's closed circle. Right. And then we have this piece. Notice how this arrow kind of just like skirts around to 0. So it actually doesn't hit 0, it just gets really close to it. And then it goes up forever. So technically this is just -infinity to infinity. But you can separate it if you want. I would take both of those as correct. right, last one. Try it on your own. All right, domain, again, we're going to have two intervals. So farthest left is an arrow, negative infinity. Farthest to the right, okay, so I hit this point, right? 2, but I don't reach it, right? And then there's a gap, right? But notice between 2 and 3, there's no blue graph there, or purple, or whatever color that is. So we're then jumping over to 3, and it's a bracket. And then we're going to infinity for the arrow. Right, so that's the domain. Now let's look at the range. What's the lowest thing we see? The lowest thing is -8. And then what's the highest? Now, this one's a little tricky. A lot of kids want to tell me 8, but it's not. Because look at we have an arrow over here going up. So it's actually just -8 to infinity. So what I get a lot of is -8, comma 8, and then 2 to infinity. The problem with this is, remember, you're not supposed to double count things. This interval includes 2 through 8. And then this interval also has 2 through 8. So you're double counting, which is why you shouldn't do it like that. It should just be the -8 to infinity. That's it. Practice. It's a lot, the homework. But you can do it. I have confidence in you.